a hyperbola, A is the distance from the center to a vertex. This is also the length of the semi-transverse axis. B is the distance from the center to a covertex, or the length of the semi-conjugate axis. C is the distance from the center to a focus. The equation that relates those three is a squared plus b squared is equal to c squared. Notice this is the same as the Pythagorean theorem, but it is different than the equation we used for an ellipse. So watch out for that. The standard equation of a hyperbola, that should say horizontal hyperbola with a center at h comma k, has the equation x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. The equations of the asymptotes would be y equals k plus and minus b over a times the quantity x minus h. For a vertical hyperbola, again, with the center at h comma k, our equation is going to be y minus k quantity squared over a squared minus the quantity x minus h squared over b squared is equal to 1. The equations of the asymptotes for a vertical hyperbola would be y equals k plus or minus a over b times the quantity x minus h. Notice the difference in the equations for the asymptotes. In a horizontal, it's b over a for the slope. For a vertical, it's going to be a over b. Some key differences between the equations of a hyperbola and an ellipse. You have a minus sign in between the two fractions, whereas the ellipse equations had a plus sign. Note that in a hyperbola, a will not always be the biggest number, but it will be with the positive term, the one that doesn't have a minus sign in front of it. Okay? And for a vertical hyperbola, notice that the thing that changed was that the two numerators switched places. Whereas if the ellipses, it was the denominators that changed places. Some comments about the asymptotes and where that equation comes from. If you remember your Algebra 1 days, let's back up a second. Okay, the point slope form of the equation of a line is y minus y sub 1 is equal to m times the quantity x minus x sub 1, where m is the slope of the line and x1 comma y1 is a point on the line. We can modify that equation slightly if we add y1 to both sides. We get y equals y1 plus m times the quantity x minus x sub 1. Because both of the asymptotes of a hyperbola will pass through the center, you can use the coordinates of the center h comma k as your point x1, y1. M, our slope rise over run. Well, in a horizontal hyperbola, our rise is going to be going up b, and we're going over a to go from the center to the corner of where our asymptote is going to pass through. In a vertical hyperbola, your rise would be a and your run would be b. Now for your second asymptote, right here we have a rise of negative b and a run of positive a. So we get a positive b over a and a negative b over a, or vice versa with the vertical hyperbola. By substituting in the values of h, k, and the a and b values in for the slope in x1, y1, that's where those formulas for the asymptotes in the hyperbola are going to come from. The y equals k plus or minus b over a times x minus h, and the vertical hyperbola equation as well. So it ties back to point slope form. All right, let's look at an example. We're going to identify all the features of the hyperbola and make a graph. For the equation, the quantity x minus 3 squared over 4 minus the quantity y plus 5 squared over 9 is equal to 1. We know this is a horizontal hyperbola. You can tell I forgot to change some things when I modified my PowerPoint. I'll fix that before I upload the PowerPoint itself. But we know it's horizontal because the x term is the positive term. Okay, notice that the number underneath the x term is not the biggest number, okay? What tells us that it's horizontal is that the x term is the positive term, the y term has the minus sign in front of it. Our center is going to be the 0.3 comma negative 5, okay, the opposite of each of the numbers in the parentheses. A, the distance from the center to the vertex is 2, okay? The denominator here is a squared. If a squared is 4, then a has to equal 2. Okay, sorry, let me back up. Got ahead of myself. So because this is horizontal, our vertices are going to be 2 spaces to the left and the right of our center, which puts them at 1 comma negative 5 and 5 comma negative 5. B, the distance from the center to the co-vertices is 3. Since b squared is 9, b has to equal 3. Our co-vertices in a horizontal hyperbola will be above and below the center. So 3 spaces above and below the point 3 comma negative 5 gives us 3 comma negative 2 and 3 comma negative 8 for our co-vertices. To find our foci, we're going to use a squared plus b squared is equal to c squared. If we substitute in 2 for a and 3 for b, or hey, here we have a squared and here we have b squared. So if you want to directly substitute in 4 for a squared and 9 for b squared, you can do that as well. 4 plus 9 is going to give us 13 for c squared, which means c is equal to the square root of 13. Our foci are going to be square root 13 spaces to the left and right of our center, which gives us coordinates of 3 plus and minus square root 13 comma negative 5. Our last feature that we need to find are our asymptotes. Since this is horizontal, that's going to be y equals k plus and minus b over a times x minus h. So if we substitute in 3 for our h, negative 5 for our k, and 2 for a and 3 for b, we get y equals negative 5 plus and minus 3 halves times the quantity x minus 3. To make the graph, I wish I had a way to show you step by step what I'm doing, but I will talk through it for you. The first thing you're going to put on your graph is your center. So our point at 3 comma negative 5 is right here. Then we put on our vertices. Okay, so 2 spaces to the left and right of that gave us our 1 negative 5 here and our 5 negative 5 here. Then I'm going to put my co-vertices on. 3 spaces above and below my center took us to the 3 negative 2 and the 3 negative 8. Once I have my vertices and my co-vertices, draw in your guiding rectangle. You can see that here with the blue dotted line. After you have your guiding rectangle, draw in your asymptote through the diagonals of that rectangle. And then you can draw in the 2 curves or branches of the hyperbola. Start next to an asymptote, go through the vertex, and next to the other asymptote, same on the other side. Start by the asymptote, through the vertex, and next to the other asymptote. And then to plot your foci, square root of 13 is in between 3 and 4. So if you go in between 3 and 4 spaces to the left and right of your center, you end up with these 2 points in purple here. Let's take a look at a very similar equation, for example, 1b. Notice that all that happened here was that I switched the y and the x terms. Okay? So we're going to identify all the features and graph. Y plus 5 quantity squared over 9 minus x minus 3 quantity squared over 4 is equal to 1. So this time we have a vertical hyperbola because the y term is the positive term. The x term has the minus sign in front of it. Our center is the point 3 comma negative 5. That doesn't change. Common mistake is people always want to use the first number and then the second number, but pay attention to which one's with the x and which one's with the y. Now, a is always with the positive term, so a squared is 9, a is 3. So the distance from our center to our vertices is 3. Since this is a vertical hyperbola, 3 spaces above and below. Our center is going to be 3 comma negative 2 and 3 comma negative 8. B squared is 4, so B, the distance from the center to the co-vertices, is going to be 2. Since this is a vertical hyperbola, the co-vertices will be left and right of our center. So this time the co-vertices would be the points 1 comma negative 5 and 5 comma negative 5. Finding the foci the same way. C is still going to be the square root of 13, but because this is a vertical hyperbola, that's going to be above and below our center, so we get 3 comma negative 5 plus and minus square root 13. Same idea with our asymptotes. Now if we substitute in 3 for h, negative 5 for k, 3 for a, and 2 for b into the vertical hyperbola asymptote equation, we get y equals negative 5 plus or minus 3 halves times x minus 3. So again, if I'm making my graph, I would start with my center. I would plot my vertices. I would plot my co-vertices, draw in my guiding rectangle. Once I have my guiding rectangle that contains the vertices and the co-vertices, I would draw my asymptotes through the diagonals of the rectangle, and then we can sketch in the two branches of our hyperbola. Start by one asymptote through the vertex, end next to the other asymptote. Down here, start by this asymptote, go through the vertex, end next to the other asymptote, and you can also add the foci above and below the center.